everybody. Hello from your favorite artist electronics, Mr. Q12 here, with a new advancement in my project here with the LCD project. I hope you remember this folder structure that you are seeing here from my last videos, and this is another folder that I recently made, and let's enter in it. It's called LCD bit B, or bit by bit. I have an about text here, you can see it, and let's read it together. Here is the file that is tested and worked in reality with settings bits and data bits functions, these two functions, one by one, BitBang. And you will see exactly what I mean by that in a second. I know you don't understand everything in this line at the moment, but you will get it in a second when I will open the program. This is the most important line. This is a test program. This is not a functional program that you actually use it. I only tested to see if it's working, and so far so good. I got very good results, and that's why I'm making this movie to show you the advancement and the progress. So let's open this file. This is a Arduino file here, and as it says here, settings bits and data bits. Actually, I keep the same program as I was having it before, but if you remember from my last video, this config is actually here in the setup. The setup and the loop functions are the only two Arduino functions that they must run all the time pretty much for the program to actually work. And this config is inside the setup when it's opening. This is the opening stage, the starting up of the program. This is what this setup it means. And the loop is running continuously. When it is starting from this bracket and when it's ending at this bracket, it's starting again from the beginning of the bracket. There, that's the function. That's what this loop is doing here. For the moment, it's not doing anything. It's not looping anything. I'm only setting up some stuff inside this function here. So clear as mud? All right. So again, this config is already mentioned here. So this entire function, where are you? Here, this entire function here is called there in the starting of the program. But as you can see, I comment out this send command with this data bits that I'm having there for the LCD to turn it on. Instead of this, I write another function that is doing exactly the same thing, but is actually bitting all these internal bits that you are seeing here on this inside this parenthesis. So it's doing the same thing. Where are you? This is the one, setting bits. And if we are looking here in the setup, so this is the config. Inside this config, I have that comment out line, and that comment line, which is the last line actually in this config function, and that line is actually this setting bits is another function, but is spilled out like water inside this setting bits, and there is clear. So it's the same configuration, the same thing as before, the same code as before. I only tweak some little parts from it. So this setting bits is this guy here. So pretty much what I did, let me actually open the last, I don't remember which, yeah, probably this was the file that I was looking into. So I will open it like this. So you see it's a very different text format here compared with what I'm having. So it's easy to compare one to another. So this is the config, the original config. It's actually using it here in this config. This is the original function, okay? So I will mark it like that. Here it is commented out. So it's not valid, it's not used in this function here, but it is used in this setting bits. You see, I actually put some markers, some helping comments here. So this is actually the config part, and I copy paste this part here. You see, it's the same, exactly the same thing. And all this stuff that is here, all these lines are actually used until it's reaching this line, and this line is skipped, but it's not actually skipped because inside this function, this line it is skipped, but I reproduce it, I remade it with this function here, setting bits. So this is the last line from this config function that I'm having it here, but bit banged. All this entire function is doing what is doing this line here. It's the same thing. This is actually the beginning of send command LCD1. You see this comment there. So you see LCD1. All right. Inside this send command function, this is a function that we made it here, and you can see it here. Here is the same command. You see right on the top of this config. And inside this send command is starting with this line, digital write. Let me actually do it like this. Yeah, like this maybe. I don't know. Like this, then, and order up. Okay, so let me do it like that to have them side by side to be easier to explain stuff. Where are you? Same command, this one. So this line here, I actually copy pasted from here, and also this line here, the last one, you can see it also here. You see it is the same thing. It's absolutely. And here I actually marked end of send command, and all this mambo jumbo that you are seeing here from here to here to here, it's actually these two lines inside this function. So this one is here. You see this tree is actually how many times it should count. So you see, I actually put a number here, 1, 2, 3, and then I stopped. And then, and you can see this is the actual line. I commented out here. So shift out bits 3, 0, B, 1, 0, 0. You see it here. You see, it's the same thing. And this is how is internally working pretty much. And how do I figure out how is internally working? Because this shift out bits, this is another function. And let's look a little bit up here. This is the function that is accessed that is called here. So this is the function here, and it's having a for loop. It's a very nice shifting function. So in this third function, we have these 3 lines. This value here is actually used here. Is the only place where it is used. This is setting pin low, as you can see here. This is the code. And this x is equal to count, which is passed here. So when you see here, the 3 that is mentioned here is actually passed into this count variable, and this count variable is equal with this x. So when this x equal to 3, decrement, go towards 0, and when you see it's 0, terminate the for loop. This boolean, I don't know, it's true or false, or 1 or 0, or high and low. It's the same thing, but it's working with a boolean value as well for some reason. I don't know why. It's very interesting usage of a boolean to open and close a pin from Arduino chip. Yeah, it's pretty much setting this data pin it as true or false because of this boolean value, but also it means it's high or low, or 1 or 0. So it's starting with 100, with 1, 0, 0, and this is the order 1 here, 0 and 0. You see it from here. You can very intuitively can make the connection from here to here. You see, you can actually see the binary form number, and also here, but displayed vertically. You see, for each of these things. And here I'm using only this last 2 bits. So all this 1, 2, 3, 4, 5, 6 zeros. So it's 1, 2, 3, 4, 5, 6. You see, and 1, 1, 0. You see, 1, 1, and 0. And this is from 1 to 9. You can see it here, shift out bits 9, and is this line which we are jumping again here to shift out bits, and is again these 3 lines, but repeated 9 times this time. Okay, because it's this second line here. So this is the code is translated in a sense. We are translating, we are splitting the code to actually BitBang. So we are making this pin data 0 for all these 6 parts, and then we are making it high or 1, and another 1 here, and then 0 again, because this is the code that we have to send to this chip, to this HT1621B. That's what all this stuff is doing. And let's see. May I see this one? I believe this one. This is the model that I'm having it. Yeah, you see, and here is what the datasheet is saying. This 100, and you are telling the chip that you are sending a command. We are sending this 100 first. These 3 lines here is this, and right is 101. If you want to actually display something on the chip, and we will see it here in the data bits. You see it here. This is 101. You see this one when we are writing this part, this setting part, which I kind of suck. I'm good, but not that good. You know. So this is, like I said, this is the command 100 that you have to send it first. So this is the bit banging that you have to actually make this data pin high and then low, low. And after 3 beating, you are beating it 3 times. The chip understands that he has to switch to interpret everything that is following after as a command, pretty much. And let's see the actual command, this 110 at the end. I believe here it was. Yes, this was the table almost at the end of the file. And here is the LCD on command line, pretty much. So you see 1, 1, and 0 we had here. This X, actually, let me scroll down a little bit. And we will see here in this note, X, it means don't care. Doesn't matter what you are putting there. If you are putting a 1 or a 0, doesn't matter. What he cares about is all these 8 bits, but the 9 doesn't care about it because it is not probably implemented. I'm not completely sure what is all that about. So this is the line. It's actually 8 bits, you see, here. But he is expecting 9 bits. You are beating that pin 9 times. It's like a security thing. It's a bit confusing, but it's part of this implementation, not for everyone to actually drive it that easily. In the same time, it's probably a hardware problem that they had to address when they make it, but also in the same time, they are not letting quite everyone to drive this chip, to be a little bit more hard to drive. That's my interpretation. This is how I'm saying it. So this is all these 8 bits that you are seeing here. Is this guy here. You see 4 bits there, 6 zeros, as you can see here, 4 and 2 zeros, and then 110 is this part here, 1 1, and doesn't matter, I could put there a 1 or a 0, but I leave it 0 because it's easier to visualize. I should have put there an X actually there. You are obliged to add a 0 or a 1. It doesn't matter what you are putting there, but you have to put it. That's the rule. And here, this last line, like I said, is this line here in this send command, and here is the end of the send command, and we are actually finishing this LCD on the actual command. So this is for the configuration command. I only split only one single line, but when you have to actually run all this, you have to do it for each of this. How many are there? 1, 2, 3, 4, 5, 6. So all these 6 lines, like this setting bits here for each line. Okay, clear as mud? Now, let's go to the data bits, because this is more fun and more easy to understand, probably. This send command is a little bit more abstract, maybe. It's not that easy to visualize. By the way, what this send command is doing, what this number is doing, and this was very hard for me, actually, to visualize and to understand when I first started to work with microcontrollers in general when I was very young. And later on in my life, when I was still bumping into this problem, what the fuck is doing all this fucking number? What this is representing, this is actually an address. You are like you are writing in your browser here, www.artstation.com. Okay, so everything I wrote here is by hand, and when I'm pressing enter, this is the address that you are sending on the web, and you reach this page. Right now I give you an example. Okay, this is what it means. This is an address actually, and this is how I'm visualizing what it's doing. It's having a number of bits. This is actually a byte of memory, and it is also called a register. Setting. So this is a setting register for the internal working of the chip. So the IC or the microcontroller is using these settings registers inside it, and you are using a phone number. This is like a phone number, like an address or like a web address. You know, you are typing all these numbers. It will point you to one of these houses. You see these little squares are like little houses or little pages, but actually it's a little square. Literally, it's a little square of memory in which it is stored a 1 or a 0, and that's it. And this call number is pointing to one of these specifically, to that one or to that one or to that one or to that one, depending. So my LCD is probably the last one, somewhere there or there. And usually this is actually having, let me erase the last one. This one, let me erase it, because usually it is having, a register is having 8 bits. So this is 1, 2, this is 2, 3, 4, 5, this is 5, 6, 7, and 8. And 8. Roman letters, 8. These 8 bits they are setting the chip how to behave. They are setting the outputs and the inputs, what to turn on or turn off. This chip, how to perform and how to enable or disable some pins of it, not all the pins, only specific pins. And in this case, it is enabling this LCD bit. In this case, like I said, this is a little bit more abstract and more harder to understand. And it took me a couple of years actually to understand and to visualize. That's the key word here, to actually visualize what the fuck is going on. Why all these numbers? Why all this shebang? Why do you have to do all this fucking around? And remember, this number here is what we are passing, and we are actually shifting here, from here down, from this line here. This command is actually sending all these bits here, but before it is actually sending 100. So this actually is longer, 100. This number is actually like this. You see, let me put it like that, and let's make an abstraction of that 0B. So it's 100, and then this 60, and then 110. So this is a very long number, address number, that you have to send to that register, and to pick, literally to pick one of those boxes and to set it as 0 or as 1, pretty much. That's all this is doing. And when you are turning it off, you are actually making one box 0, and when we are turning it on, we are making it 1, that box. So it is clear as mud right now. Okay, so this is about the configuration bits, which are a bit more abstract and more harder to see. At least for me, it was for a very long time actually, and I had to grow a very bold head for it to completely grasp it. But I hope this will help someone out there that is having the same issues and the same problems as I had in my youth. And I hope this functionality or this mentality, I really hope to be a general information and not so obscured information, because this was not explained well at all by anybody. By any tutorial that I've read it, I've always got some very obscure explanations, very complicated, absolutely unnecessarily complicated explanations, because those people, they didn't know how to explain it better than that. And we grew with that kind of explanations, everybody, I believe. And I was one of those people, and it was very, very, very hard for me to understand exactly what that guy was explaining there. And usually it was written tutorials, not video tutorials like I'm doing it right now. All right, let's go further. So we finished with this setting bits thing, which was this line here. Again, this is the line that I commented out, and I'm splitting it into bits, literally, that single command. Again, you have to do it the same to use this entire code for each send command that you are seeing there. Okay, let's go to send data, that one. So in this setup, we are calling this configuration function. We are adding this extra setting bits, which are setting one single line of bits. This is all that is doing. We are clear it, to 0 everything, exactly as before, nothing changed. But here we are actually sending data. And at this point here, I comment out this line. I'm not using it in code, but instead of it, I'm using this data bits. So this data bits represents this. We are actually writing the segments on the LCD. This is what is doing this data bits function that I made there. It's a function that is sending bit by bit the address to the chip, to this HT1621B chip, which is very close to a microcontroller in a sense, and it's quite interesting chip to learn with. It's a step lower than a microcontroller actually, this chip, but it's pretty much the same mentality, is the same way of doing things as you are doing it with a microcontroller. So in my book they are on the same step, on the same page, both of them. You are commanding them the same way. And here we are setting the address. I showed you before the starting bits 101, the right, this is the line here, but here is a bit weird. Yeah, they are telling you the address bits here, starting with address 5, address 4, 3, 2, 1, and 0 until here. This is the addresses. So all these addresses, they mean 1, 0, 0, 1, 0, 0, whatever. It's like this here. They are 6 bits here, and they represent these 6 bits, and it can be 0 or 1. That's why they made this notation. This is data, only 4 bits, and I showed you before. Code sample this, and let's see. Here is the, you see, this is the memory structure. One line is an address 0, address, this other line is address 1, this other line is address 2, address 3, and so on until address 31 is not having that many addresses. And these are the digit or data bits. This bit 1, 2, 3, 4 is this 0 data bit 1, 2, and 3 is 0, 1, 2, 3 is 4 of them. And they represent these 4 little squares that you have to address them. Okay, this is actually the address. This entire thing is the actual address, and it will open or close one little square like this, and one little square will be closed or open. It will actually open or close one single pin from all these multitudes of outputs that is having, because all these pins are outputs, and it's very good that it's having all these pins. It is looking very menacing and very hard to understand when you see how many pins it's having, but if you are reducing everything to only in and outs, it's a very good thing. And actually I'm happy to work with many pins chips like these ones, and that's why I like it. That's why I'm making all these movies, because it's easy to work with this kind of almost kind of parallel. Having multiple pins, it means parallel, sending parallel data, but it's actually a serial. You are commanding it, you are sending this address in serial. In the end, it's transmitting the data to the LCD in parallel mode per each pin. So that's what it's doing actually. So all these pins from the chip are linked to these pins from the LCD, and they are opening one segment there. Okay, let's see the actual function. It's exactly the same as before. So send data, this line that is commented is actually this line that you are seeing it here. Let's see on the original file here, it was this line is changed. So here it should have been 0. You see, this is address, and here it should be 1. To be exactly, probably I played a little bit. So these 2 lines are these 2 lines here. On whatever bits I want to open up, those 2 or this 3, because this one is not implemented, but here on address 1 it is all 4 are implemented. That's why you are seeing this little line. This represents that this bit is not implemented, is not used in the chip. Okay, so this is the line that we are starting to emulate in this data bits function. We are starting like this. This is the line, and there's this one here. Let's go inside the send data function. Let's see where it is. Send data. Here it is. Here is the actual function. Send data. You may make the difference. This is another function quite different from the send command, because it's counting 3 times and it's counting 9 times. But here is a bit different, because it's sending the starting bits, is counting 3 times, then 6 times for the address, and 4 times is counting for the actual value that is sending to the chip. As we've seen here, these 3 bits here, these 6 bits for the address, and these 4 bits for the actual data. So that's very complicated stuff. So that's what this new function is doing. So right now we are inside it, and we are starting with this digital write. So we are sending this CS, are making it low. So this is the first line here, and here I copy paste it just like before. And this last line as well, we can see it here. This is the last line. Probably I should put here, just to be clear, the end of this data bits end of the data bits command, and save it as well. And we are having these 3 elements, 3 lines here, and we are getting inside this shift out bits. As you can see here on this line, we are getting inside this shift out bits function, and it's here. So it's the same function for the send command and for the send data, and we are jumping from here into here pretty much, and it's the same thing as before. This is the number for this variable count that will be equal with the x inside this 4. This is equal to 3, and then decrement like 3, 2, 1, and 0. When it's saying 0, is jumping out from this for loop, and that's it. This is the shifting function. And this is the count, and this is the actual data 101. Like I said, is this the ID or the starting bits of the address. This 3, 1, 2, 3. You see it here, and is, as you can see it here, 101. You can also see it here, 1, 0, and 1 here. So it's very easy to visualize it this way when you are writing it in binary. And we are actually getting this address through this variable, which is actually passed here, address 0. You see? So this address 0, when we are sending the data, we are passing this 0 here, and it's taken by this address variable, and then it's passed into here, into this function. And this is what 0 means. This 0 is written 6 times. You see, 1, 2, 3, 4, 5, 6, and all are 0, 0, 0, 0, 0. If you want to write not to the 0 address, but to the 1 address, so right now we are writing here at this address. But if we want to write to this address here, to address 1, we are changing, I believe, this guy here. So this will be 0001. The last thing is the actual data, and the actual segment that you want to lit up from this LCD display is these 4 lines. Very, very simple to use after you understand what the fuck is going on. And this is the last line here, as you can see it as well here. You see, shift out bits for value. And where value can be anything. In this case, can be 0011, and this is 0011. Let me change that back to 0 there to actually write on the 0 address. And it will mean this A, B, C segments of the LCD. This is the A on the top there, B and C lateral. And this value is actually this variable value that we are seeing here, that we are sending it from here. So this value here is passed here into this variable, and this value is used here. Function is taking this value from there, 0011, and is passing it here, and from there this val of Boolean type is used here. Again, like in the address, it is true or false because it is Boolean, but in this case, for this function digital write, which is Arduino intrinsic function, it may accept true or false as well as 1 or 0. So that's why I used this 0011 to this line that I'm having it here in the middle. They also represent the same value that we are seeing it here. You see, so 00 is this line, 00, and 11, it means 1 and 1. And we are lighting up only A and B. And the C, so this is A, B, and this C is off. And let me start my camera. All right. I already have some data there already written from before. So this is the explanation of all this test code. And as you observed, I only expanded a single line from the configuration bits, the setting of the chip. Only one single line, I change it. The entire code is running normally as before. I only intervene and change and modified and expanded and BitBanged only this function, only one function, this one, because it was simple. That was for the settings, and only one single line of code for the address and the data sending command. So that's it. Only 2 lines of code I modified. That settings one and this data one. And you can see it here, this data bits that we are using it here instead of this line. So it's only 2 functions that I modify in all this entire program. It is looking complicated, but it's necessary for actually figure out how to manually BitBang it later. In reality, without the need of a microcontroller or even Arduino. But Arduino was immense help. I cannot wrap my arms around it, how immense it was, the help it provided. I couldn't do this with a PIC microcontroller. What we are seeing here, it was close to impossible to do it with a microcontroller from a microchip, like a PIC microcontroller. It's way too hard to write in assembler this type of exercise that I'm doing here. And be aware that there are much more complicated codes than this. This is like a medium code. It's not simple, it's not very complicated. It's kind of medium code. Okay, let's stop talking. So this is the last point I wanted to make about all this code, because we finished with the code right now. And this is the last point I want to make about these 2 lines of code that I comment them out and I modify them. That's all about what this project is about. This LCD BitB project, this project here, this one, this red one, this is all that it is about. These 2 lines of code that I modified them and actually BitBang here the address of the chip and then the segments of the LCD. That's it. Okay, let's see it in action. Actually, to change the data bits, to change the segments from this function, from this BitBang function for the data, I cannot do it for the settings bits because the settings is the settings and it's harder to see it. But here is very easy to see when we are changing it from here. Do not fucking motherfucker, Dracula. 3% on my battery. So I had to put a wire on my camera, a charging wire, because the battery just from 100% in a couple of minutes I discussed here, it just terminated its battery. Unbelievable. So now I mounted it again with a wire. Let's actually start the experiment and let's see. So as you can see here, I'm having these 2 bits two segments lit up. These are from address 1 remained. This is segment A, B, and only C segment is lit up and showing. But when I will upload the code, let's see, only A and B, only this and this segments will lit up, and it will form a little square here, and this segment will disappear. So this is what this code will actually do, and let's upload it. And let's see if it's actually working. Yep, it's working. Okay, so let's change another bit here. Let's leave A. Okay, let's change, so B as 0. Let's turn off all of them and upload. So right now it will disappear, those two. And let's open them one by one, I suppose. Let's open this A on the top, upload. So it will lit up only this one on the top. It will be like a C, little C. You see? This is like a little C. And then let's open this one, the C segment, upload. And it will lit up this guy here. There, you see? And this is the last one. Here, this one is uploaded. And it will lit up that one. Ta-da! Ta-da! And that's it. Let me change it back as it was before, because this is a test program and I want it to preserve it as this for future, looking backs. And this is it. This is the entire thing that I did. I know it's probably you are wondering why all this trouble, but you will see in the future when I will actually do some interesting stuff with it, with this blow up code, this blow up functions, these data bits and these setting bits. So pretty much I will have to program something with these setting bits, something else than an Arduino, to receive all these setting bits, all of them, all those 6 ones. So all these commands, I will have to actually use this kind of setting bits per each command line. And then with something outside of Arduino, of course, like we are doing here with this data bits function, which is this one here, we are sending the start bits first, then the address, and then the actual bits, these 4 bits. I want to do it manually, probably from some logic circuits like flip-flops, counters, probably multiplexers at some point. I'm not completely sure, but that's my target. That's what I wanted to do. And retrospective, if you remember from my previous movies, if you are a Fidel watcher of my entire series, I discussed this problem a long time ago, but I will bring it up again. How easy it is to program an integrated circuit that is having parallel inputs. How easy it is to program a parallel input range of inputs of a chip compared with the serial inputs. I admit there are only 3 pins to send data to them, but it's so hard and so inconvenient, and it is not user friendly at all. Is against user friendly, is very much user unfriendly. But it is doing, after all, I managed to do this exercise and to actually really bitbang each bit per address, per settings of the chip, and per address and data of the chip. So that's very, very a big deal, at least for me, your favorite artist electronist, of course. It's a real big deal for me to reach this level and to manage to make it work like in this configuration that you are seeing it right now, and that I've explained it until here. So again, Arduino helped me immensely. I have, and also what is the most important thing, compared with PIC microcontrollers or microchip forums, the Arduino guys on the forums are extremely helpful. Yeah, I have no words for them, for how grateful I am. So it's very, very cool. They actually helped me. Compared with the microchip forum people, they did help me for a while until they figured out I'm not American. Most probably, it's my best guess. And after they figured out I'm not really an American, they literally punished me, and they literally pushed me away from those forums. They didn't like outsiders, like outside the America territory or citizen or whatever. Yeah, they are very biased people there, and it's not nice, very not nice. But well, what can you do? I learned my lesson not to blab around too much about my nationality, and yeah, to keep it for myself, because I have this a little bit Slavic accent, although I'm not Slavic at all. I'm European jet by jet. And the last point is how cool it will be to actually be able to make money with all this knowledge, with all this knowledge and experience and expertise to actually drive something as complicated as this. How cool it will be to actually make money in this capitalism we are living into. It will be a real dream come true, for at least for me and for those like me. Not only for me, because I am a single person, but there are others. Other people smarter as me and even more smarter than me, but they have the same poor situation they live into without any means of getting a job, a normal job, a normal salary, not just freelancing bullshit with $5 per month, $5 per month or bullshit like that. No, that's bullshit. Normal salary like everybody else. How cool it'll be. It'll be very, very cool. Yeah, well, I didn't ask everybody. Indeed, and I didn't move places. I only stayed at home and I didn't move around too much, and that's on me. But it should be interesting and it should be an ideal to see that is possible on the internet, online, to actually get jobs and with salary, like with normal salary, with real money, with normal money. And it will be a dream. It will be very, very cool to see it. I didn't see it. I never seen it, at least here in Romania, or at least here in my side of the Romania, in my city. It's just a myth. It's just a mythological story about how about getting money on internet. In reality, it's not happening at all. It's just a rumor that it might be possible for some special people, but not everybody is special, and not everybody is getting those kind of money. Maybe one or two or three, very few, but it's not the same for everybody. Really, everybody. So it's not a large scale event getting money from internet only. You have to suffer the fight with stress. You have to get out there and win at the fight with stress, with other people, mentalities and perceptions and way of life. Literally, very, very different from what I'm used to. And what I'm used to is quite normal, but yeah, not for everyone. All right. Thank you very much for staying with me, for listening, for understanding what all this project was about and what it will. And I hope you will make some thoughts and imagine what it will come next and be excited about it, because I am. And I hope I will manage to push it to the end of this project, because this was a quite complicated one and I really want to finalize it and to put a stop end on it and to call it finished. And it is not finished yet, and it will be very interesting to see it finalized. I really hope so. I will get there soon enough. All right. Thank you very, very much for staying with me, for listening, for watching, for understanding everything I said, as complicated as it is. I hope it's not that complicated anymore right now, as it was before watching my movies. And leave a like, and I say you goodbye from your favorite artist electronist, Mr. Q12, forever and ever. The forever Q12. All right, bye-bye. I'm poor, and I'm sick of everything, physically and psychologically. Bye-bye.